all the roots of the polynomial z to the 6 minus 10z to the 5 plus az to the 4 plus bz cubed and so on plus 16 are positive integers, possibly repeated. What is the value of b? Interesting. All of the roots are positive integers. So I guess what I might try and do here, it's funny, there's like some algebra theorems, some advanced algebra theorems that might actually work on something here. They're all positive integers, possibly repeated. What I think I'm going to do is just write, I'm going to factor this polynomial as a product of degree 1 terms and see if we can figure out, just expand things and see if we can figure something out. Okay. I'm not sure if this will work, but let's write the original one. Z to the 6 minus 10 z to the 5 plus a z to the 4 plus b z cubed plus c z squared plus dz plus 16. Okay, and I think the key here is that that's the product of all the roots. 16 does not have a lot of factors, right? They're all going to be powers of 2, of course. And is that the sum of the roots? I don't remember how this works. So this is z minus, let's call it z1, z minus z2, z minus z3, z minus z4, z minus z6. Oh, why did I skip 5? That's funny. 5 and z minus z6. Okay, so z1 multiplied all the way up to z6, that's equal to 16. So, I mean, that's only 2 to the 4. So I know quite a few of these roots have to be 1 because all the roots are positive integers. So a lot of them have to be 1. And what is the meaning of this term? The thing on z to the 5. So how do I get z to the 5? I get it if I go z times z times z times z times z times 1 root, or if I take all of the z's there and that root. So the sum of the roots, z1 plus up to z6, that's equal to 10. Okay, so maybe we can figure out now what these roots have to be. They multiply to 16 and they add to 10, and they're all powers of 2. One, 2, 3, 4, 5, 6. Multiply these together, we get 16. Add them together, we get 10. I guess that's the only way to do this, right? Well, hold on. What if I go like 2, 2? What if I want there to be a 4? 4. So now we multiply to 16, but we don't add to 10. What if we go 4, 4, 1, 1, 1, 1? That doesn't add to 10. Yeah, I think it's got to be that, right? So now how do I find coefficient on z cubed? I don't really want to just multiply things out. Z minus 2 to the 4, z minus 1 squared. Do I want to find like the ways of making z cubed from what's 6 choose 3? 6 factorial over 3 factorial, 3 factorial. 6 times 5 times 4 divided by 6. There's 20 combinations. Do I want to add, do I want to just go through them one by one? I mean, in this, I could think about a general way of doing this, which would take some time, or I could just go through, oh, what is going on here? Or I could just go through all 20 combinations. Or I could figure out how many combinations contain exactly one of these, how many combinations contain two of these, and figure it out like that, perhaps. Okay. So there's 20 combinations. So I want to count how many combinations of all these things have neither of those. So it's just, that's going to be 4 choose 3, right? Which should be 4. How many combinations have exactly one of these? Well, let's say it's that one. And then we have 4 choose 2. What's 4 choose 2? 4 factorial over 4 is 6. But I have to multiply by 2 because there's 6 where we choose only that one and another 6 where we choose only that one. So that's 12. And I should be left with another 4, right? But let's make sense. Let's confirm. If we choose both of them, then the third one, there's 4 choices for the last one, so that's 4. That does add up to 20. So if we have none of them, the product is -8. If we have exactly one of them, the product is -4. And if we have both of them, the product is -2. So the answer, I think, B is equal to -8 times 4 minus 4 times 12 minus 2 times 4. -32 minus 48 minus 8. -32, that's -40 minus 48 is equal to -88. I mean, I think my approach here is about as straightforward as you could get on this question, putting things together. I hope I did this counting correctly and that stuff correctly and the arithmetic and so on. But yeah, this is all about recognizing, just putting together a few things, the information we're given. I think thinking of it as in its factored form like this is a key. Understanding that this last term has to be the product of all the roots. And that tells us that because all the roots are positive integers, all the roots have to be powers of 2. Understanding that this is going to be the sum of all the roots. And that tells us what all the roots are. I'm fairly certain this is the only combination of powers of 2 that multiply to 16 and add to 10. And then the combinatorial stuff here kind of worked out. Yeah. So that'll be my answer. But if I have a mistake somewhere, I'll let you know. Thanks for watching.